In a recent episode, I walked through the process of creating test doubles and verifying those test doubles in RSpec. We had a simple class with a method that took in an object and then returned a string using some methods on that object. And while there are times where you create methods that are that simple, I often find myself in my work creating methods that are quite a bit more complex, where there's not just a parameter that's passed in, some things happen, and then some things return. It's usually like a call to something is made, the core of it happens, and then there are other side effects. Maybe an email needs to get sent, or an API needs to be called to. And the way that last episode worked, it's nice to know what test doubles are, but there's kind of a next step for how to use those test doubles, which are also could be considered our stubs, and then mock out what happens to them and write code that tests their behavior. So let's just get right into the code, and I think that's the best way to start. So I don't have a preset code base right now for this episode like I have in past ones, so we'll just start from scratch. We'll require spec helper. I do have RSpec configured. That's the only thing in this project. Also, just got to really make it clear, it's important to have end-to-end tests or integration tests. This is an example to show a specific aspect of the work, and it doesn't include the end-to-end tests and the integration tests because I think that would expand the scope of this really large. So consider this exercise just one piece of the puzzle, and it's an important piece, but the other pieces are also important. And this isn't where I would enter into a project generally. There would be some end-to-end test that exercises the stack that gets it to this place. But what we're going to do is we're going to have an order, and we're going to add the checkout method that processes the order and does a variety of things. So with that being said, let's go. So we'll describe order. We'll run that test. It fails because it can't find order. Run it again. Fails because it can't find order. So we're just going to require order and get that green. So that's green. Now what we're going to do is describe a checkout method. We'll expand what this order class does as we get there. So we'll just say it does stuff, expect subject dot checkout to be. We'll just go really small steps for red, green, refactor. Undefined method checkout. Okay, let's get that pass. We'll just return true. Okay, great. We're red, we were green. Now we're gonna keep moving forward in the process and expanding what this does. So let's describe the stuff it does. We'll say it sets the state to process. And so let's go ahead and we'll say subject, it's order.new, and let's pass in a state of, we'll say cart. Like its state is, it's a cart, and then we'll say, okay, now it's been processed. We'll have a state of created. Let's do created, and then we'll say completed. I think that's nice. So we'll call subject.checkout, and then we'll say expect subject.state to equal completed. Let's use symbols here and all that kind of stuff. Wrong number of arguments, so we'll just define our initialize. we'll say adders. Expected completed, it got nil. Let's say state is equal to adders dot state, or we'll say that it's created, something like that. Well, yeah, I guess we could even like, I'm probably going too far with the adders. We didn't even necessarily do that, but we've got it. But it's failing now. We're getting created back as a symbol instead of completed. So then we have to, then we can just say state equals completed. And we're not stubbing or mocking anything yet, right? That's fine. But we're just going to define everything that happens. And then we'll say it. The next thing I want to do is it calculates tax based on the shipping address. And how do we want to define that? Well, I think it's sort of interesting in that we're going to do a variety of things with this, and maybe it helps to like sketch out what we're going to do. So we're going to say it calculates tax based on shipping address. It calls out to the payment process. We'll call it payment gateway with total items, totals, tax. And we'll say it emails the buyer. So could do more, but I think that covers it to start for these unit tests. So we'll say it calculates tax based on the shipping address. And this is where we're going to get into this mocking and stubbing. So we're going to define the behavior that we want to then implement with this. And what I want this to be is we're going to have a class called tax calculator. So RSpec has this syntax where you can say expect an object to, just like our expectation here, but you can say instead to receive tax calculator to receive calculate. It calculates tax based on we'll just say based on the order. So we're going to say expect tax calculator to receive calculate, and you can specify what it receives it with. So we'll say with subject, and then you have a block at the end. There's another syntax for this where you say and return. This is the same. And you're going to return an object. And what we're going to take is, we're just going to mock the return to be 10.0 as a float, just to keep it really simple, right? Because when we're unit testing order, we're not concerned with what tax calculator's calculate method does. Even though, it is important, it's not the concern of orders checkout. That would be the concern of tax calculator and then an integration test or an end-to-end test. So, so this is what we want the behavior to be. We're describing it. And then we take this and we call checkout. So when you're doing this mock-driven approach to test-driven development, which is also called behavior-driven development, you start with your tests and you define what you're expecting it to be, and then this is helping design our code, because in this world that we're fabricating, we don't have tax calculator yet, but we are going to expect it. So anyways, let's run this and see what happens. We get a failure, uninitialized constant tax calculator. That's because we don't have tax calculator. So we're driving that out. Take that, we have to require it here. If this was Rails, or if I took the time, we could auto require everything, but for the sake of this, we'll just keep doing what we're doing. I spelled receive wrong, so that caught our error. Now we have an error that tax calculator does not implement calculate. So we just gotta put calculate. And this is getting into, like, it is crossing the boundaries in that we have tax calculator coming through and we expect it to receive calculate. And I'll talk about an alternative approach to this that we could use. Calculate. It's a class method, so let's put it on self. Wrong number of arguments, right? So we'll just continue this out. And then if this was, since tax calculator is new code, in theory I would, if this doesn't exist already in our code base, I would write a spec for tax calculators, calculate method, and then that would contain the logic and the unit testing and the edge cases for calculating tax. But let's keep on with what we're doing here. So we'll see it failed because it expected it to receive calculate with the subject, but it instead expected it to receive it one time with the order, but it received it 0 times. And that's because we're not calling that code yet. So what we need to do is text calculator dot calculate self. Now we run it, it passes. If we run all of our tests, we have 2 passing and 2 pending. And we're one step closer. And so this is like a very simple way to drive out the design of the code and test it at the same time by describing what we want this to do. And now let's go and we'll say something like, okay, we had text calculator, now let's take payment gateway, which we'll just have it be this generic class to receive process payment with, and then now we get into this interesting thing where this unit test is going to require the return value of the tax calculator. And also we don't really have items on the order. So that's another aspect of this. We're gonna have to set up our test data a little more. But let's just say that it calls out the process payment, and we'll just say with 30.0. And what if we also, we'll just go with that for now for this simple example. We'll pass the amount to the payment gateway, and maybe we'll say like order.card. We'll call it like order.payment method. So we'll have like amount in the payment method. This is all fabricated, so it doesn't matter. So we'll have our payment gateway class. That needs to call process payment, right? That's run this again. I skipped a step in that it I added payment method to, or process payment to payment gateway without the failing test. So that's my bad. But let's also do this. We'll have a payment method. Get that to pass and go to the next step. Wrong number of arguments, expected 0, got 2. That's because this doesn't work, so we'll have to say amount, and then we'll pass in payment method. Run it again. Okay, different failure this time. Expected 1 argument, received 0. And let's just pass in. This is where we'll use a double, which we'll just say credit card. For payment method. We could even, something nice we could do here is we could say payment method, we could put payment method into a let block so that it's accessible elsewhere, and then we could just say, even more explicitly, we expect it to receive it with this double that we instantiate with the order. So that's nice too. We're just being more explicit in our tests of what it receives it with. So it didn't receive it because we're not calling it. So let's call it. We'll call payment gateway, process payment, total plus tax, and then we'll call payment method. This total plus tax is going to be interesting in that we didn't implement it yet, so maybe I'll slow down and we'll skip that and get it passing. Run that again. I had a typo. Okay, that passes. Let's run all the tests. It passes, but we have this fake code, right? We have this 30. That doesn't feel good. We have the tax calculator, but that doesn't do anything. So what we want to do then is figure out how to make this test, like write our next failing test. And I think we have a bad test and we need to make that better. So what we should do, I think, instead is say, for our order, let's just we'll have items be something that we pass in and let's let items be something where we have if we have items be something where it's an array and then it's just doubles because we don't really have those classes yet, we'll just say item 1, unit price, and we'll just say, actually, I'll have those have a total. We'll make it 15, double, we'll have item 2, total 5. So 5 plus 15 plus 10 for the tax gives us 30. Also, I'm using floats, but you probably want to use big decimals. But again, this is just for an example. So this expect here is interesting in that we actually need it. It's a dependency for this other unit test. So I personally would test these together because they're dependent on one another. So you can do, like here, we want it to be 30. We wrote bad code here. So we'll just make it 0, make it fail. And we can then implement what we need to do to make it work. So we have tax, and then what we'll do is we'll say items total is equal to items dot, what is it? Items dot sum total? Is that how that works? Hey, that works. So you can sum the total from the items, and we have that there. Some people may not like that there are multiple expectations in a unit test, but I think it's really important. And it's so important that you can call ordered where it actually asserts that it happens in the order that we need it to. So if we instead did this, that's going to fail because, well, it's going to fail for other reasons. Let's just hardcode this. Received process payment out of order because we need to calculate the tax first. So, when you're unit testing stuff, there's a time where you might want to have multiple expectations in a test, and that's okay. You could also do something like in your before run this, and then before each of your tests, it's gonna mock this call, and it's an expectation, so it'll fail if we got rid of it, which is nice. And then, oh yeah, the ordered is still there, which is interesting too. But anyway, I think this is nice and it works for our purposes. But why aren't we failing now? Oh, okay, I see what's failing now. Our test on 13 is because it's saying undefined method plus. So what we could do there is in our before block, we could actually say allow tax calculator to receive calculate and return 10. And that just, like, if there's code that we have a unit test that's saying state is completed, it's not testing anything else, we can pull this out and do that there, which I think is quite nice. Even though it's duplicative of this, we have this ordered expectation here that's important. I guess we could do and keep this ordered and then leave it up there, and that would pass too. So you got options. We need the tax to work for both of these tests to pass. So that's there. This is the key focus of this episode, is this syntax of expect to receive, and then you can pass with, or you call with the args that you're expecting, and then whatever it's returning, and then based on what you're returning, you then assert that in other places. And we'll drive that out. Here we'll say context when the payment processes successfully, it emails the buyer. We'll also say, we'll move this down here. It sets the state to completed only if it processes successfully. Then we'll say a context when the payment process fails. Processes, we'll say unsuccessfully to keep the same language. And this is where these mocking stubbing gets really useful, especially in unit testing, when you have this logic with context. So we won't do the emailing the buyer yet. We'll wait to do that. But let's say here, run everything, make sure it still passes. Now let's write a failing test for when the payment processes unsuccessfully. We'll say it sets the status to payment failed. And then what we need to do here is, in this context block, we're going to have our before that covers when the payment processes unsuccessfully. And we're going to expect payment gateway to receive process payment. I'm going to get rid of the with because we're not testing what payment gateway gets called with, right? That's getting tested here. Instead, we're just going to say expect payment gateway to receive process payment. When you don't specify with, it's any arguments. Don't care about the order that it's called, but instead we're going to have it return failure. So before it was success, now it's failure. Now if we run this test, it fails because it expected payment failed, but it got completed. And that's because we're always setting state to completed. So let's write some code to make this pass. We'll just say gateway, like payment, process payment status. Oops, messed up something there with them. And then we'll say if process payment status equals success, state is completed, else state is equal to payment failed. And I think we'd want to have validations for these states, and maybe they would be in constants and all that stuff. right? This is just some quick examples. Now our test passes, run all the tests, and we'll see that on line 24 our test failed in our test. So that's surprising. That's because we need to, for this context, when the payment processes successfully, we need to mock what payment gateway process payment does. That's really important. Otherwise, what was happening is payment gateway process payment was being called and it was being exercised and just returning nil. And nil doesn't equal success, so it was payment failed. So there's a run them all, they're passing. We have a pending spec, so that's why that pending one's showing up. But those are all passing. Let me just turn something off really quick. Because documentation. Let's just get rid of this. It's making noise in the specs that we don't want. Let's say when the payment processes unexpected, when the payment processor, well, yeah, we're good with this covered. We could do more examples, but it would just be more the same. So, so that covers that. Let's do the emailing, which, because we have this before block that is just scoped to this context, we're already set up here with this expect. Let's go and say this. So what we'll say is, we'll say expect mailer to receive, if I can spell receive right, send mail with, we'll say order completed, or we'll say order success as like the signifier of what email to send, and we'll say to buyer@example.com. Our test data is not properly set up yet, but we'll get there, right? Back to the same old thing. We don't have our class of mailer. So we'll create that. We'll require it. Let's run the test again. Does not implement send mail. Run it again. So it's kind of driving this out, but we'll say mail key, we'll say to address. Okay, now we have the failure we want. It expected to receive it one time, but it didn't. So then what we do is, if it's success, state is completed, we'll say mailer.sendMail. This can just be order success as a normal symbol. And then we'll say buyer email, which we don't have yet. So that will cause that to happen. Let's go and set that up. I'm just going to do some quick formatting. Okay, run the tests again. See what's failing and why. Oh, I put a paren when I should have put a quote. Run the tests again. Okay, they're all passing. So that's actually kind of nice, right? We're not testing. If this test was reaching further out, like if it was an integration test, maybe it would verify that like a fake email gets created like in the testing system, or that maybe a mailing API was called with the content that we expect. But instead, we're just saying that this mailer class receives it. And in Rails, this might be, I think there are mailer classes. I forget what they're exactly called, like action mailer classes or whatever, where where you could stub them out this way. But then here, when the payment processes unsuccessfully, if we put this down here and run it, everything still passes. So let's actually leave that there, and then we'll write a failing test. Because we want to cover that it doesn't send the email, does not send the order success email. And that's really, this is like the crux of unit testing, right? We have some logic in here where things happen and don't happen based upon the return state of calls to other objects and classes. And here's how you handle that with RSpec. And we have this width, but the width doesn't really matter because we can just flat out just say mailer to not receive send mail. Run that. It fails because this is the inverse of the error we've been receiving. Expected 0 times, but it received it 1 time. You can keep the width there, and it will still fail. And that's great for testing that maybe it's not getting it with a certain parameter, but it is getting it with another one, or it's only called once. Or there's a lot more there's a lot more to this RSpec mocking API than what I'm able to show in this episode, which I'd like to cover more in future episodes. But what I would do here is just say, it's not going to send any emails. Or we could say, like, order failure, and it sends them an email, but we'll just say it doesn't send the email. I think that's really useful. So we're combining RSpec's to not or not to with the receive syntax. Now, if we pull this up here, run our tests, all of them, they pass. So I want to get rid of this because it's making our specs noisy. There we go. So yeah, I hope this is helpful. There's a lot that's being covered here, and I'm kind of lost in the example at times, but we went from having no code to having a system where we have these classes like tax calculator and payment gateway and mailer that would have their own unit tests that cover their own responsibilities, but we need to make use of them in order. And that is, testing that can be difficult, right? When the methods aren't pretty simple, where it just takes a param and does some stuff and then returns a string like that other episode. This is more like close to the code that I find myself having to write on a regular basis. And this is how I would test it. And this expect to receive is really important. For these before loops, right, we could do allow because some people advocate for not putting expectations in before blocks because it can be confusing and like have these misleading expectations. So you can change them to allow, and all that says is that it allows it to happen, but if it doesn't, the test won't fail. So you got options there. I don't think it makes a huge difference, to be honest. Like, I think it's pretty similar, like 1/2 60 other type thing. So that's that. There is another aspect of this where I think you could take it farther, even though in a lot of Rails code, dependency injection doesn't happen. But we could do something, and I'll just do it with one example to show it. And this isn't something that I find myself doing very often, but I see teammates and other people do it, and I understand why they do it. And it's neat in certain ways in that we wouldn't have to necessarily create these tax calculator, payment gateway, and mailer classes. We can instead inject them and say like tax calculator. And then you default it to that constant. And then you could have private, adder, reader, tax calculator, class, right? Or we just call it tax calculator. That doesn't necessarily have to have class at the end. And then you do something like tax calculator is equal to tax calculator. So then we're passing in tax calculator. And then here we would call tax calculator. If we run this, our tests still pass. But then what we could do instead is in our order, we could say tax calculator is this tax calculator object, and let's create it. here we'll say text calculator, and we can call it a class double, or we could just call it a double. I think we got options there too, but we'll just say text calculator. Run the test. I missed a bracket. Run it. It fails because it received unexpected argument calculate. So then we could do here, right, return 10. And we'll see things like, oops, I typed calculator, but it should be just calculate. Then we've got these other expectations surrounding text calculator. So like, that's not going to happen anymore. So that's no longer legit. So we can get rid of that. Then we run it and it passes, right? So we've, instead of like expecting that text calculator gets called and then it returns some value, we can inject that and have it happen. We can also say expect text. So instead of removing that altogether, we could say expect text calculator to receive calculate and get rid of this 10 here. And that works. And that all passes. So that's an option too if you want to use doubles. I think if this was verified, let's see what happens. If we go to text calculator and we get rid of calculate and run that test, the text calculator class does not implement the class method calculate. So it's verified, which is cool. But here's the thing that I struggle with, which is why are we going to do it? Are we going to do that for all of these? Like, to me, you could go through all of these and inject the constants and you can pass them in and have the doubles. And what it saves you is not having to mock out the calls. Like, since we use class methods, it's kind of different. But like, imagine you had to do .new, you would do like expect text calculator to receive new, and then it returns a double, we'll just say instance double text calculator. You know, there's like this approach you can take of mocking out the instantiator, returning another double, and then mocking the double. So you can say expect calculator to receive calculate 10. That's another option, and sometimes you can do that. Like sometimes that has to happen. Like if this was something like this, if you had to initialize the calculator with new, and then like this kind of thing. But oops, we needed that instance double. I spelled receive wrong. So it all depends on like what you're working with and what your what you're working with in the terms of classes that you have and what you've got. Like here, we would have to do new self calculate, right? That's the problem why this is failing. So now if we rebuild that API here, oh my goodness, but we're passing in text calculator here, which is the class double and doesn't receive new. We could instead we could just get rid of this because we defaulted the text calculator. Get rid of this. Oh, but then I actually added this payment gateway. Sorry, I'm in the... There we go. So now we're green again. This is how you could do dependency injection with the class and then instantiate it. But to me, I don't really see the big deal or the problem with just doing calling out to the constants in the class. So I think that's up to you and the people you work with and how you want to work. But for me, I would just do what we did originally in the episode. Whew, that is a long tangent. Let's get back to what we had with green tests. Okay, we're green. That feels good. Thank you so much for watching this. There's more to cover with the syntax here. I will definitely talk about it, ways we can expand upon it, and handle variation, and maybe like we don't have control of certain objects, or they're being passed in from other places, or whatever it is. Cover that more in the future because there's more steps to take, but I hope this gets you started on like how to drive something out with RSpec by mocking and stubbing and making use of this behavior-driven expect syntax, and then using before loops to mock out what happens to drive out logic, like branching paths and logic in your code, because it's really important that this is tested, I think, especially for such a critical system such as like an order checkout. Thanks again for watching. I really appreciate it, and have a good one.